Okay, number 20. We've got a chart with a line of best fit. And Michael swam 2,000 yards on each of 18 days. Those are 18 data points, it looks like. The line of best fit for the data is shown. For the swim that took 34 minutes, so note we've got time in minutes on the x-axis and heartbeats per minute on the y-axis. So for 34 minutes, which is right there, that must be that data point. His actual heart rate was how many beats per minute less than the rate predicted by the line of fit. So we're exactly one vertical grid below the line of best fit. Here's the key to all of these problems. Make sure you know what your grids represent. They're not often one by one. In this case, it looks like even though the horizontal looks longer, the horizontal here represents 33 and a half, not even to 34, only halfway. So the horizontal is 0.25, and the vertical looks like we're going 132, 4, 6, 8. So it looks like that narrow vertical is 2. Well, that's not what you would necessarily expect. So here, we're one vertical grid away from our line of best fit. That means we're 2 away. The correct answer for number 20 is B, 2 heartbeats per minute. 21. Of the following 4 types of savings account plans, which option would yield exponential growth of the money in the account? Okay, so remember, exponential growth means we have a percentage or fractional change from the previous period or the previous term. It is not a constant rate of change, and it is not a percentage or fractional change from the original amount. Okay, so let's read through and which one represents a percentage or fractional change from the previous period. A, each successive year, 2% of the initial savings is added to the account. No, that's simple interest, right? That's not 2% of the previous amount, even though they put each successive year. Little tricky, but watch that. A is not correct. B, each successive year, 1.5% of the initial savings and $100 is added. No, again, it's not a percent of the initial savings or a constant amount added. Those are not exponential functions. C, each successive year, 1% of the current value, which is the previous period's amount left over, or remaining amount, is added to the value of the account. That's it. It's a percentage change on the remaining or previous period's amount. C will be an exponential function. D, each successive year, $100 added to the value of account. That's a linear change. It's a constant rate of change. C is the correct answer for 21. The sum of 3 numbers is 855. One of the numbers, x, is 50% more. So x equals 50% more. Well, that's really 100% plus 50%, which in a decimal equivalent is 1.5 times. 1.5 times, or 50% more than the sum of the other 2 numbers. So x equals 1.5 times s. We'll call s the sum of the other 2 numbers. Okay? What is the value of x? Well, we know the sum of the 3 numbers is 855. X plus s equals 855. Now, I'm going to substitute in 1.5s for x over here, and I'll get 1.5s plus s, which is 1s, equals 855. That means 2.5s equals 855. S equals 855 divided by 2.5. So in this case, again, we could probably run the math ourselves. Now, in this case, I would probably run the math on a calculator. S equals 342. Okay? And the only reason is because the answers are for x. We're not done now that I found s. we need to figure out what x is. So remember, x equals 1.5 times s, which is 1.5 times 342. Now I can run a quick estimate. It's going to be 340 plus 170. It's going to be just over 510. X equals something just greater than 510. The correct answer is going to be B, 513. It's the only thing in the ballpark. Now, another approach I could have done, I could have actually substituted back in for x and solved for x in the first place. Might have saved me a few seconds, but doesn't make a difference in the end. The other thing students might want to be careful about on this particular problem that might mix them up is if they thought about three numbers, a plus b and then plus the x equals 855. They might get caught up between the a and the b and figure, okay, I can set up two equations, but I have three variables. I can't solve for a and b. And the answer is you can't. But don't get confused by that. You don't need to. What you need to solve for is x, and you can treat a and b as essentially one variable, a sum like we did here. We called it s. I don't need to break them out separately. That's just going to create confusion and potential problems for you.